And guys, I'm very happy to present to you Emanuil Slavov. He has more than 14 years of experience in software testing. He's currently the head QA at Confo. And I'm going to tell you, last year I was on a testing conference here in this very same venue, and this is when I attended Emanuil's talk. And it's a very great material, and I think you'll all enjoy this talk about shift left, his concept about finding bugs as early as possible.
Thank you. Thank you. Yes. Can we do the thing? Oh. Click. Oh, yeah. Okay. So hi, my name is Emanuil Slavov. I'm going to talk about how to build robust automation testing framework. I'm not a developer, so don't run away. I'm more of a testing guy, but pretty much all of this stuff is relative to you. If you have any questions, keep them for the end. I will finish in about 35 minutes, so you'll have time then. When I say this to my wife, she's very pleased. I'm usually a 3-minute man. Okay, so let's go. Okay, so no matter what organization you're in, big company, corporation, startup, you will face the same problems over and over again. And in my experience, I've seen these things over and over. So the first thing is the cost of bugs. You've seen probably this graph, which shows that the earlier you find the bug, the cheaper it is to fix. The later you find that, it's very expensive. Sometimes your customers find SQL injections, hackers hack you, so it's pretty. You also have a reputation loss in this case. I'll show you how to fix that later. But you need to be aware that this is the whole shift left mentality. Try to find as early as possible the bugs. The next thing is humans. We work with humans. And as humans, we are very fallible. We tend to fall in love. We tend to get drunk. We tend to get distracted. And we also hate repetitive tasks. So there are some tasks that we, as a human, should not do. A machine is better to do those tasks. Try to figure out what those tasks are, so don't bore your humans. Also, humans are expensive. I've been in the IT business here for more than 14 years, so I remember the first time my first salary was about $180 a month, so it's pretty cheap. So now it's not like that, but humans are expensive, so you don't want to waste human time, human effort to find things that automation computers can find. And the next thing is speed. If you live in the 21st century, you probably have competitors on your market. So it's all about speed, faster delivery, first to market. I was in a company where they were 3 developers in a team and 5 QA guys. So more QA guys than developers. This was not Microsoft's early days. But the reason was that because there was no automated test whatsoever. So even a single line of change would result in 3 days of full testing. This was a system that deals with a lot of online money, online transactions, so it had to be pretty bulletproof. So developers would have to wait for 3 days to get feedback of one single line of change. Is it good, is it not good? So this is the next thing. You need to have speed. The thing is, you need to detect the problems early, okay? So this is obviously a problem. So, this child will have a problematic future. So you need to address those issues as early as you can. And the best way to do that is use the machines, use the computers. It's quote from the Matrix, so never send a human to do a machine's job. Can you spot the human here? It's over here. So he's picking up something, I don't know. But there are tasks that are better suited for computers, not for humans. Okay, so we need to figure out what those tasks are. Today I'm going to talk about Swiss cheese defense. What Swiss cheese defense is, it has also other names, layered defense, defense in depth. if you have a slices of cheese and you have holes in it. So if you have a problem, it may pass through the first slice, the second slice, but usually the third or the fourth or the fifth will catch that. It mainly comes from the military doctrine where you don't have only one line of defenses. If you're in conventional type of war, you have minefields, then you have barbed wire, then you have trenches with soldiers, then you may have tanks, artillery, and at the end, if everything else fails, you have the atomic bomb, okay? It solves everything. But this is the last line of defense. You don't want to use that. So for our purposes, there are different levels of checks. So you line all the checks, and you run all the automatic checks after every commit. Why after every commit? Because you need to know who's responsible for this. You don't want to have nightly builds, nightly checks, because in the morning you don't know who exactly broke the build. So after every commit, you run everything that you get. The key is for everything to complete in 5 minutes. The average attention span of a developer is 5 minutes. After the 5th minute, you committed your code, and what you do is you open Facebook, you open your email account, you surf some porn site, you go to the bathroom then you eat something, and not in this particular order, but you get the idea. You have 5 minutes basically, okay? So average developers, okay? You're PHP developers, so I don't know, but so average developers, 5 minutes. You have 5 minutes to give feedback, okay? And the next thing is you have to arrange those slices of cheese to the fastest to the slowest. If you have a problem, you need to be reported fast, super fast. So arrange those fast, slow. So that's the famous automation testing pyramid. The idea is that you have layers. So at the bottom are the most checks that you do on your whole code base. Those are cheap tests. Basically for PHP, for our case, this is static analysis of the code. You have a lot of checks there that don't do any execution at all. The second layer, the middle layer, those are your unit tests. They execute code, but that code is only in memory. You don't have your application deployed yet. I'm going to talk about this later. At the top of your pyramid, the least amount of tests that you should have is the black box test. They may be API tests, they may be testing through the UI, but on the black box test side, your application is fully deployable. So the database is there, you have connection to the external services, and also those are your slowest tests and the ones that fails the most, because you don't control all the conditions. So this is a testing pyramid. You should have the test in your case should look like that. It should not be inverted ice cream cone like that. No unit tests at all, and only automated tests through the UI with Selenium. So the first line of defense is linter. I assume some of you heard of that. Linter, it's built in PHP to catch the most basic errors. Syntax error, for example, as you can see here, we have some developer was committed some code and he forgot semicolon at the end. So I use ID, so ID usually screams with errors, but you can see the little squiggly red line here. Means that I forgot basically a syntax error. Now, if you use a compiled language, the compiler will complain about that. But PHP is an interpreted language, so I've seen projects where there are a lot of those kind of problems in production. Obviously, the code does not execute a lot, but still, you don't want a human to catch this error, okay? You need to have computer catch this error. So the way you do that is php-shell and the name of the file, and it will say that you have parse error on line 61. So basically, it goes line by line. It's pretty simple and also pretty cheap test to set up. You set up only once and you forget about it. Okay. Next is HSVM. Some of you were on this presentation. This is your second line of defense. I'm not going to go into details of what HSVM is and what it does. It stands for Hip Hop Virtual Machine. We don't use that to compile and run the binaries. We use that as a means to more advanced detection. So it can detect stuff like, it has an analysis engine, so it will detect stuff like if you try to call a method that is not defined yet. Sometimes you mistype something, okay? And if you don't use ID, the ID will, you will not know that you call something that does not exist. So the checks are a little bit more advanced. It shows you errors such as if you try to use a variable that is not instantiated before, or if you use output from a void method, and so forth. So more advanced than the linter. This is the output that you get. There are about 30 or 40, I think, errors that HSVM can detect. Again, those are errors that are cheap to detect by a computer. You don't need to compile, to build everything, give to the QA guys, and the QA guys to tell you after one day, hey, we have a problem here. You have to catch this instantly. The problem with this is that Facebook decided to abandon the analytics mode. They have other priorities to work on the hack language. So if you want to use this, you need to use version no more than 3.5. So I'm not aware of any other alternative for that, but it's really useful. So your next line of defense is PHP mess detector. So PHP mess detector will detect some problems that are not immediate bugs. For example, linter, it's a bug 100%. PHP goes to this line, it blows up. HSVM, again, a problem. Code method does not defined, blows up. PHP mess detector detects a lot of stuff. It's a question of whether you should use all of them, but two other main important checks that you need to care about if you care for your long being of your project. So psychomatic complexity, your developers, so probably you know that. This is a simple method that doesn't have any conditions in it, so it has psychomatic complexity of only one. Means that there is only one path through your code. The second method, it has one if statement, so now there are two paths through this code. So if the if statement is satisfied, and when the if statement is not satisfied. The easier to think about this is whatever the number of complexities to the method, the same number of unit tests you should write so that you cover all the different paths. So a bunch of guys gathered in the 70s, in the 80s, and they made a lot of researches and said that the optimal number, again, for average developer that have 5-minute attention span, should handle methods of complexity of no more than 10. Because you're the same as a juggler. So the juggler juggles balls in the air. You can only have so much balls in the air. Okay? If you have too much balls in the air, they start to fall. And so if you work with methods with bigger complexity, you tend to get a lot of accidental errors because you probably heard this, you guys, the developers again. I've touched here and this thing breaks. Okay? I don't want to touch this method. It's too complex. Let Ivan do that because he's an expert here. I don't want to touch his code. Since PHP is a little bit more dynamic and it's also loosely typed, sometimes you don't know what the variable is. You don't know if it's an object, if it's a string, if it's a Boolean. So sometimes in your code you do checks for is array or is string and so forth. So relax this a little bit, but again, no more than 15. So real life example. You may have heard about Toyota having this problem, which is unintended acceleration. You drive on the road, and at some point, your Toyota starts to accelerate for no particular reason. This is an actual car that was in such accident. The driver was lucky; he hit a wall, but yeah. But 12 other people were not so lucky. They fatalities, 12 people. So at the end, 2009 or 2010, Toyota settled this for a $1.2 billion settlement. So there were a lot of investigations into what exactly happened, what exactly caused. We still don't know the exact causes, but on one of the lawsuits, there was an expert who was reviewing the firmware code of the Toyota. So he looked at the method, the function, that has to do when you press the acceleration button, what happens and how many gas is put to the engine to accelerate the car. So the complexity of a single function was more than 100, which is, these are his words, is pretty unmaintainable. There is no way that you can write a 100-unit test for a single method without going crazy. I really hope that Toyota get their act together because I'm also driving a Toyota. So. The next thing that you should care about in PHP mess detector is Samuel mentioned in the previous presentations, method size. Again, no more than 100 lines, ideally 50 lines of code. You should fix the method on a single monitor screen, depending on which monitor you use. I've seen guys, turn their monitors like that. But, don't cheat on that. I mean, single responsibility principle. Your method should do only one and one thing only. Your life will be easier about that. But the thing is, you want to detect those problems the earlier they appear.